Welcome to video number 2 in my series on differentiation rules. In this one, we're going to take a look at e and the logarithm with base e, the natural log of x. So let's start with e. Given the function f of x equals e to the x. This particular derivative is pretty interesting because f prime of x in this case would just be e to the x. This is the only function that exists where the derivative function is the same as the original function. So for example, if we have f of x equals 4e to the x, in my previous video I said constant coefficients don't matter, so the derivative of this will be 4 times whatever the derivative of e to the x is, which is just e to the x. So let's try an example, but tack on an extra term just to up the challenge. If we have f of x equals 7e to the x minus 4x squared, to find f prime of x, the derivative of the first term, 7e to the x, would just be 7e to the x again. And for that minus 4x squared, we would apply the power rule. Derivative of 4x squared, 2 times 4 will give me 8, times x to the 2 minus 1 power, or first power, which is just 8x. And now we'll move on to the other part of this, the inverse of that e to the x function. We'll start looking at the natural log. So given our function f of x equals the natural log of x, this derivative also a pretty simple one to look at. For the natural log, f prime of x is equal to 1 over x, 1 over that input. So just like e to the x was the only function that stays the same when you differentiate it, the natural log of x probably has the most significant change in form when you differentiate it. You lose the logarithm and you turn this into a fraction. So for example, let's take f of x equals negative 6 times the natural log of x. For the derivative, the constant multiple in front is not going to matter, so we'll have negative 6 times the derivative of the natural log of x, which is 1 over x. And combining those pieces, our final result is negative 6 over x. Now let's look at one more. We'll look at f of x equals 5 times the natural log of x. And let's tack on an extra term with that. Let's add 2x here. The derivative of 5 natural log of x will just be 5 over x, or 5 times 1 over x. And the derivative of 2x, well, that's going to undergo power rule. So it has an exponent of 1, so 2 times 1 is 2. And the exponent will go down to 0, and x to the 0 is just 1, so we don't have to worry about writing it. And so hopefully you're not finding those too difficult. Let's just try one final problem, putting it all together. Give a slightly longer function with multiple terms. We'll set up g of x equals 2 times e to the x minus 10 times natural log of x plus 10x cubed. When we see something like this, we just go term by term. I see 3 derivatives I have to take. So for g prime of x, the derivative of that 2e to the x is going to stay exactly the same, 2e to the x, minus the derivative of 10 natural log of x, which will just be 10 over x, plus the derivative of 10x cubed by the power rule. 3 times 10 gives us 30x to the second power. And so that's it on dealing with e to the x and the natural log of x, also bringing in a little bit of a reminder on the power rule. And next steps are working these into application, but also working with problems where you're going to have to use multiple rules at the same time. Thank you for watching.